delay. Um, my name is Ifoma, and I'm here to take you on lesson three. So lesson three is a quantitative method. Can you all hear me, please?
Yes, we can hear you.
Thank you
Yes.
very much.
Yes.
Thank you. So lesson three is a quantitative method. This is in chapters 5 and 6 of the text, a recommended textbook, and that's from chapter 5 covers the quantitative method and ways to conduct the quantitative research, while chapter 6 covers how to interpret quantitative results when conducting a research using quantitative methods. So I'm going to kind of go back, give you um, a kind of recap what you did about how to conduct your research in the last two lessons. Um, you have to, first of all, when you want to conduct a research, you have to start from the research scope to understand what you're trying to work on. What is your topic? What do you actually want to research? How do you want your research to, how do you want to formulate your research, including the research questions? All these will help you to understand, first of all, the when you formulate the scope and also formulate your research question, it will help you to understand, the broader parameters of your research, what you need to study and what you do not need to. That's the area, the main focus of your research. And also it helps you to understand the target population which you need to research and the study duration. This includes also the time frame and most importantly, the methodology you wish to apply in your research. In this case, this will be the quantitative research. So when you have your scope and you understand the scope of your research, you will be able to know the type of methodology to apply to be able to conduct that particular research. For this topic, for this lesson, we are going to delve into the quantitative research. And if one might ask, what is quantitative research? And it simply means collection of numerical data or variables that is required, as I said before, to be able to answer the question and also to be able to look at all the areas of the research you want to get into. So when you collect your data, the data could be nominal, ordinal, or interval scales. And when you taking it further, the variables you need for your research could be dependent variable, independent variable, extraneous and intervening variables. You can refer to page 116 to 119 of the recommended text, and you'll be able to read further and understand about these types of variable and how they also influence your research. So when you collect your data, you'll be able to measure and score and count and be able to interpret your research reports and make inference from the results you've gathered from the research. So formulating research hypothesis, as I've said earlier, before you move further with conducting your research, you need to know that you need to formulate a research hypothesis, which helps you to deduce the relationship between the variables under studies. It can be null hypothesis, which means that when the result does not agree, you understand, when maybe it does not agree to the test you've conducted. And it can also be alternative hypothesis, when it's accepted. When it's rejected, it's not hypothesis, depending on the results from your research. And when it's not rejected, the alternative hypothesis shows that the hypothesis is accepted, which means the result is accepted, and you can be able to interpret your result based on the test of the significance from the sample and the p-value, and then you can interpret the results of your hypothesis, whether it's null or alternative, in the research. Then there is research design, which is correctional research design. This measures relationship between the variables under study. And then there is experimental research design. It helps us to understand the cost and effect from the independent variable to dependent variable. And also we have the quasi-experimental research design, whereby you need to manipulate the independent variable to establish effects on dependent variable. From what we've gathered so far, let's look into the cross-sectional data analysis. Cross-sectional data analysis simply means when a given data about a given population is collected within a given time. For instance, if I want to measure the effect of trade openness across sub-Saharan African countries in 2024, I will collect data across these countries, but within the year 2024. That is cross-sectional data. And the data collection can be numerical data, questionnaires, or interview, which can also, in some cases, um, the cross-sectional data can only be in the form of questionnaires only, especially when you want to gather information probably about a given sample of a population. You can use a questionnaire or interview. Sometimes you can also do it across countries, depending on how the form of or the form of research one is conducting. That will also determine the type of data the individual needs to be able to do the cross-sectional to use the cross-sectional data and the analysis. So in some cases, the cross-sectional data is somehow preferable because it shows it is less expensive and less time consuming because it's collected within a given year, and one does not need to keep maybe trying to spend more to go over years in order to collect the data. But the downside of it is that sometimes the data might be very big, and also it's impossible to test the causal relationship when you're using the cross-sectional data. Then we have the panel or longitude panel data. Panel data will have multiple entries observed over more than one period of time. Like I said before, if I want to measure the effect of government spending or the trade openness across Africa, I can do that from 1994 probably to 2024. I will not just do it within a given year, a given period. It will be across a period of time to be able to measure the trend and also to be able to understand what's happened within those period covered. So it could be a mixed method. You can use a mixed method in panel data, a mixture of quantitative and qualitative data. And also it gives opportunity for comparison over time. the downside of this, which can also be overcome, especially when you are using panel data, is that the data could also be complex. But if you understand the result and how to interpret results, it can always be, one can overcome the issue of complex data in panel data. Then this is a summary of different regression forms. Looking at this, you can see that in the first part, when you want to set your regression equation, when you want to set your regression equation, looking at this, you will see the equation for cross-sectional data. You also see the equation for panel time series data and that of panel data. When you want to set your equation for those analyses, you need to make sure that the equations are set accordingly, depending on the methodology one adopts for the research. Also, when setting the equation right will also help in the interpretation of results, because when you finish doing your regression analysis, you need to understand the equation you set, and that will help you also to be able to interpret your results accordingly based on the findings obtained from the research. You can also do use the autoregressive distributed lag model in a panel data, or the generalized method of moments, that's GMM, when you're trying to conduct a panel data analysis. So here we just have to look at techniques for cross-sectional data. But before I go forward, I just want to know if anybody has a question so far based on what we've covered.
If Dr. Iwekunam, Ifoma, I can maybe
Yes.
just mention to the students that they are on my UNISA. If they go and look at the lessons, there are examples also that they can go and look at cross-sectional data. I've
Okay.
put in a study that we've done also a few years back, and it's precisely what you said. It's maybe more for 1 year if you want to do maybe over a number of variables. You want to look in 1 year, maybe the pass rate of a certain subject. We looked specifically at public economics, and it was quite interesting to see how the pass rate is being affected by different factors. Excuse me, such as, for example, demographics, and we also use binary data in between. So that's just to give an idea, but the students can go and look at that themselves in my UNISA at the lesson specifically for that. Thank you.
Okay. Thank you very much, Prof. So we can move forward. So when you want to conduct a research, we have what we call the population. And within a population, because you cannot conduct a research based on the whole population, you need to extract a sample from that population to be able to conduct a research based on the given information or the given scope of the research the individual is trying to work on. For this area, for this side, we are going to look at the population, the sample within a population of a research, and how we can apply the descriptive statistics based on those population to be able to analyze some of the results we have um, from the research. This is also contained, all the results I'm going to look at now are also contained in the text, recommended textbook. But as we go forward, the dates and the pages and every other thing are there. You will see the pages. So for example, when you want to um, look at maybe a population in a given institution, maybe University of South Africa, for example, and you want to see the number of male and female students there. Um, this is a kind of this descriptive statistics. You look at the male students. In this case, you see the number of female students. You also see the number of male students as contained in the university, and also the total number of students in the university. So you use this to a kind of um, analyze the population, to understand the sample of the population you're working on, to understand each of the population. Um, this is also a race of students in first year class at a university. You can also look at the sample, maybe the black, colored, and white, and then the Indian. This is you when you are looking at a race of students in a first year class at a university. This is a sample of the population by race. Then there is what we call the frequency distribution um, of a sample. When the data is normally distributed, we have this kind of the mean, median, mode. We have this kind of distribution where everything is within the equal size of the population. Now, this is the frequency distribution again when it's skewed. It can be skewed negatively or positively, as the case may be. But when this kind of a situation occurred, the one can also take steps to be able to normalize the data, to be able to carry on the research, as we will see further. Then this is a kind of the descriptive statistics and the inferential statistics as contained in the recommended textbook. Some of the characteristics of those sample, when you are looking at the sample using those like descriptive statistics or the inferential statistics, these are some of the characters one needs to observe while working with those methodology. Now, looking at the sample in front of us, is just a descriptive analysis of COVID-19 data. As you can see, it has the sex, the race, the age, birth dates, whether the patients are diabetic, education, COVID-19, BP, height, and weight. you know when you're working with a data, one needs to be able to observe this kind of sample. Maybe the data, you look at the variable, and you can be able to apply it while conducting your research. You can also see here the height histogram. Looking at the sample, you will see that the histogram is skewed. So when you're working with a data like this, you need to a kind of normalize the data before you continue with your research to be able to get the expected result in your research. This is also a chi-square test. Looking at the chi-square test, you will see the sex. We are looking at just the sex of COVID-19 patients, and to be able to understand probably the percentage of male students, or the frequency of male patients, female patients, and also the total number of the patients in the that have COVID-19. So you will see the chi-squared, but looking at the you can also see the probability results down there, which is 0.05%, and also the chi-square, you see that the number of male patients is 82%, while the number of female patients is 91%. Those with COVID, over a given period of time, you will look at it and see those that have COVID-19, and also in a population of 63 male, the number that has does not that has COVID-19. Then the test result for weight and diabetes. This When you have a result like this, you first of all look at the group and also the sample. This is a two sample t-test with equal variance. What this result shows us is that at 95% confidence interval, that's a percent 85% of, yeah, you can call it 85% of people are also overweight, looking at it, while 77% are not. So with um, the results, the p-test results, which is at 0.067, you will see that which is at 10%, is very weak, though it's significant, but it's a weak significance, which shows that weight, there is the relationship between overweight and having diabetes, excuse me, is, though is significant, but is very weak. Then this is a one sample t-test for weight. You looking at it, the results is also highly significant at 0.07 percentage, which means that overweight can also influence diabetic patients. Diabetic patients can also, in some cases, be overweight. Thank you. This is a example of ANOVA results um, between groups and within group, which we had interpreted in the book. Looking at the probability is highly significant. Then the Pearson correlation test, the normality test for GDP and exports. When one, assuming one has a sample or one is conducting a research to understand the effect of GDP, the effect of exports on GDP, looking at the results, you will know that one will see that there is a positive relationship that exists within GDP and exports if in this given sample or in this given result. Then there is a scatter plot of the GDP and log of exports. Just when you are looking at the sample, showing that the sample in some cases might not even be, the sample might not be a normal sample, but though there is a relationship, but the relationship might not really be, it might not really be a straightforward relationship between the two variables. Excuse me. And this is also the result of the test correlation between GDP and exports. Excuse me.
Hmm. Are we done?
No, we are not
Not,
done,
no,
please.
not done.
Come in. Yes. I don't even know what I clicked.
So while Ifoma is busy looking at that screen,
Okay.
I just want to remind students to please go and do the discussion forums also. They are there for discussion so that we can help you also with those. Thank you.
Thank you, Prof. So this is correlation. This result shows the correlation result between GDP and exports. Looking at a sample here, we can see that there is also um, a positive correlation between the two variables. Then, when we want to use a Wilcoxon test, um, looking at the sample here is a two sample Wilcoxon ransom test, and is also an observation using COVID-19 patients, and looking at the results between it has to do with age, COVID-19 patients and the age of those who have COVID-19. The result is positive, and so you have to look at the probability. It shows that the result is positive, and also that there could be it shows there's a positive relationship between COVID-19 and probably within the much older individuals in the society. So COVID-19 is much more higher with the individual society. When you go back to the textbook, you will see the whole interpretation there. And this is a Kruskal-Wallis test. When you are doing your research, looking at this one here, it has the Asian black, colored, and white, and it has the chi-square test and the probability. So you use the probability when you want to interpret the chi-square test. You use the probability to be able to interpret the chi-square test here, and it shows the result. Then this is the equation for regression analysis here. I'm not sure if this is actually showing what I did, because um, simple regression, this is just a regression between two variables, a very simple linear regression. And looking at the regression, the assumption that the error time should have constant variance, and also the assumption that the residual term is normally distributed. So this is a sample of a simple regression model, and you also have the probability here, which shows a high significance, and for the age and BP, once again, that there is a, a relationship, there's a high relationship between age, um, the age, maybe individual's age, and the probability of the person having a BP. So there's a significant relationship with there. Then this is a test for homoscedasticity. You look at the chi-square and also the probability. When the probability is positive, it means that there is a positive relationship between the variable under study. Multiple regression model here. Here you have to use, here we have multiple variables. Maybe there will be independent, multiple independent variables that can be able to affect or determine the independent variable. That's simply what the multiple regression analysis um, refers to. And as we can see here, the probability is high again. Looking at the I square, R square is also high. So you can be able to deduce that there is also a relationship, a high relationship between age and also maybe gaining weight having being overweight in this type of research. Then logistic relationship. In logistic relationship, we also try to use the probability to be able to determine a relationship between the variable. All this has to do with maybe whether there is a correlation and how significant the variables are. So when you want to measure all this, you have to look at the chi-square and also the probability. And based on that, you can be able to interpret the result and make an inference whether there is a relationship that exists between the variable or not. Then simple logistic regression with categorical variable as independent. You can also look at it here from the chi-square, then the probability, and also the pseudo R square. They all need to be observed, and based on the interpretation given on the book, you can be able to look at this result, or to be able to interpret whether there is a relationship between the variable and also how the other variable, in this case female and sex, female and COVID-19, excuse me, and um, be able to determine whether there exists a relationship between those variables. In this case, the chi-square is at 0.05, which is at 1% level, and you will see that there is a relationship, a high relationship between the variable here. And that is it. Thank you. Any
Thank you.
questions so far?
Yes, thank you so much. Any questions like Dr. Iwekunam asked? Kevin, no more? No questions? Have you maybe come across these examples in econometrics? I believe we've got no response, so it must be new work covered, but I'm sure you've done some econometrics. Anybody?
Hello,
Yes,
can you hear
Kevin.
me?
Yes, we
Yes,
can hear
we
you.
have. I just wanted to
Yes,
respond to your question. Yeah, I have come across most of these examples in econometrics.
wonderful, wonderful. So, yes, so we just revising some of the work. It's actually we duplicating some of the work to make sure that when you go over to your honors or your masters or your PhD, um, that you'll know that these methods exist. As she said, time series, panel data, cross-sectional data, and all of that. So yes, I think she gave a great overview. And just a reminder, please, the assessments are open. uh, Please go and do those assessments as soon as possible, because Easter is coming up, and we would like you to do those. Especially the quiz you'll see is more on quantitative methods also. And then assessment one is also still open, but it's not open for submission. It is open now for you to go and peer review your classmates. Okay, so just to make that clear. Linda, Mrs. Stone, maybe anything from your side?
No, I don't have anything to add. Yeah, thank you for the very nice class. I also actually learned quite a bit. Thank you.
Yes,
Thank you.
thank you so much. And
Thank you.
yes, have a great day. Thank you, Foma.
Thank you, Prof. Thank you, Linda.
Okay, the
Bye-bye.
Thank you.
students can go. I just
Okay.
quickly want to speak to the lecturers.
Okay.
Bye, Kevin. Bye, Norma.
Bye bye, Kevin. Bye bye,
Cheers,
Norma.
cheers. Bye, guys.